I would like to take this opportunity to welcome everyone to the Autodesk Eagle webinar. Today, we're going to be showing you how to use the Eagle Library Editor and make components as well as edit them. We also want to take and demonstrate how to create a managed library, a system that works in parallel with Library.io and Eagle. Before we begin, I think it's a good idea that we introduce ourselves. George, what do you think?
Sounds good.
Give me a second. Okay. Well, my name is Edwin Robledo. A lot of you may know me as Ed, and you could see our posts on the forum. I've been with Autodesk and working with Eagle for a very long time, and I'm really excited about all the new improvements that have been done by Matt Berggren and his team of developers. They've really improved how the workflow that you use in Eagle and can exponentially lower the amount of time in your design. With me today is another one of our support specialists that has been working with Eagle for a very long time as well, has a really strong footprint in our forums. George, can you say hi, please?
Hi, everyone. How are you doing? As I said, I'm a product support specialist here at Autodesk. Been using Eagle for the last 10 years almost.
Excellent. Well, I'd like to remind everybody that during the presentation, you could post your questions using the chat option. We will also host or have a Q&A session at the end of the presentation. But before we actually begin going live with Eagle, there's some terms that I would like to go ahead and define and show you. That way, those that are kind of newer users to Eagle, we're all at the same platform. Now, let me just give you a brief description of exactly how the library editor works in Eagle. The library editor in Eagle is basically a platform that has embedded 3 editors. Is that about right, George? It's like 3 editors.
Correct.
The 3 editors basically consist of the schematic symbol, the package, and the device. So let me give you a brief description of what each one does. The schematic symbol is where you're going to create the logical symbolic representation of your package. The package editor is actually taking into consideration the actual footprint. This is what it's going to look like on the board in Eagle, as well as when you get your boards back from the manufacturing house. And the third and the final step is actually putting everything together. In other words, this is where you're going to take your schematic symbol and your footprint, the package, and you're going to assign one of the pins on the symbol and assign it to one of the pads on the package. And that is considered what's called the device, and now it's ready to be used in the schematic. So we're going to be talking about the schematic symbol, the package, and the device editor throughout this presentation. But there's some more terms that I want to go ahead and clear out before we actually begin. Now, you're going to be hearing us talking a lot about managed library. So before I go there, Eagle is an ECAD application that has a continuous workflow with a mechanical application. This capability empowers our users to interact data between Autodesk Eagle and Fusion 360. This is accomplished by establishing a data-centric system by which both applications can share data with no need of file conversions. Yep, we have solved that issue. No more fighting DXF, IDF, step conversions, which are prone to so many errors. A portion of that data-centric system is based on managed libraries. Since we mentioned managed libraries, let me explain what it is. A managed library is a mirror image of your local library, which is available on Library.io and provides you the capability to map 3D step models to your package. There's a lot more to Library.io than just hosting your libraries, and I'll get back to that shortly. Log into Library.io using the same Autodesk credentials you use for Eagle. Here you can access your managed libraries and assign step models to your packages. In addition to the mapping capabilities, Library.io also includes a package calculator, which will make it really easy to create a package and an associated 3D model in one step. These packages can then be accessed from the Eagle Library Editor, and I'll get back to that really soon. We get that question quite often, George, such as, hey, I need a step model or 3D model to associate it with that package. So now including the package calculator in Library.io and accessing it from Eagle. Actually, we solved that. What do you think?
Yeah, I mean, we're still going to make other improvements as time goes on. We're going to bring more of the functionality locally into Eagle. But definitely for now, this is a workflow that you can use to get ahead and be able to do the interaction between ECAD and the MCAD world.
Excellent. Now, let me just go over briefly about the three editors I mentioned earlier. We said about making libraries consist of a symbol, a package, and a device. The faster we can make our symbol, the faster we can make our package, then we could get to our to the device editor as fast as possible. Making sure that creating parts is actually a very simple, easy thing to do. Now, I want to talk a little bit about the symbol editor because recently they've added some really nice features that I want to be able to highlight. That way everybody knows that they actually exist. The first thing I want to talk about the symbol editor is Smart Paste. Smart Paste actually allows you to select the names of the pins that are going to be used on your symbol and paste them in the eagle, and you will automatically get those pins attached to your mouse cursor. Okay, so you select it. As you could see on my GIF file, I'm selecting the names of my pins. Once I paste an eagle, I get those pins. Now, the only thing is that when this is done, the pins are actually going to have the same function and the same, and they're going to have the same function and the same direction. Okay. Now, there'll be times that maybe you have a very large component and you like to use a system by which when you paste them into Eagle, they already have their function. Let me explain a little bit about that. The pins in Eagle actually have a property. Those properties include the pin name, its angle, its direction, passive, its length, its function, if it's going to be a clock or not it, and if you want them to be visible, visible meaning if you want the pad name to show up or the pin name to show up or both to show up. I could actually now create what's called a smart paste with headers. Basically, it will consist of creating an ASCII file with the headers, and each header is going to be the name of the function of that of the properties of that pin. I could copy it from an ASCII file and paste it into Eagle. Now the pins will actually be brought into the schematic symbol editor with the appropriate properties. Did I get that right, George?
Yes, you did, Ed.
Okay. So, we got that question quite often, that can I create components using a spreadsheet? Well, part of it is there already. So you could just copy paste it into a spreadsheet or into an ASCII file and just paste them in the Eagle, and their functionality will actually be brought in as well. Now let me move on to the package and what we have done to the package editor to make things a lot easier for you. In the package editor, we've actually embedded a package calculator. This package calculator uses a parametric option which allows you to select a package as a template. Now you go ahead and enter the specifications of that package, and not only will it create the package for you, but it will actually associate the 3D model for it as well. This saves you a lot of time. Now, this package calculator is being accessed from library.io. So in other words, this is kind of a cloud-based system which is actually working in parallel with our library editor as well. Now, the next thing I wanted to let you know is if you already have packages on your library.io account, in other words, if you have managed libraries, library.io will actually collect those packages and host them there as well. Also, library.io also includes the package calculator, which allows you to create packages. Well, guess what? You could actually access those packages directly from the library editor in Eagle, giving you the opportunity to be able to reuse packages that you've already created. Not only that, you could actually use packages that are available in Eagle in your already created libraries, which already have an associated 3D model, and you could actually use those in your new libraries as well. Okay, did I miss anything here, George, so far? Excellent. Show off his skills. So we're going to just take a second, that way we could switch here really quick.
Go ahead and get started then. So as you can see here, we have Eagle 9.01. It's right now running on the free version. I'm going to go ahead and open up this base library that I've set up for this demo. So you can see the base library is very straightforward. It just contains 2 devices, a few packages, so on and so forth. So what I'm going to do is I'm going to go ahead and click Library, Create Manage Library. Now I think it's probably going to ask me to log in. In fact, let me actually change because it's probably logged in as Ed right now. So let me go ahead and do that first before I go sign out. Yes, I am. Okay, sign back in. Okay, everyone look away. Don't look at my password.
I'm closing my eyes. Don't worry.
No one will know. Okay, awesome. So now what we'll do, now I'll open it, because I want to make sure it goes to my account. So what you have to do is, this is a normal Eagle library as it stands right now. It has not been managed. The way you can tell is, if you look at the top, when it's managed, you'll see that it will say managed. If not, then it's a normal base library, a normal standard library. So first thing we're going to do is going to go Library, Create Manage Library. This checkbox is important, okay? Because you start off with your local standard library, and when you make it managed, it's basically creating a new copy on the cloud, and then that copy is what's being downloaded back into Eagle. So if you don't archive it, what you're going to see is that you have 2 copies of the same library with the same name. One will be managed, the other one won't be. And if you know what you're doing, that's perfectly acceptable, but it can create confusion. So generally, it's best to leave it archived. You're never going to lose a library. It's simply going to be relocated to this archive location in the installation directory, where it will be safe and it won't be in the user. So the one you'll see in use will be the managed library. So we do encourage leaving this checked, but if for whatever reason you want to leave your local copy where it is right now, you just uncheck it. For now, this is okay. So click Create. We'll see it's processing. It's going to upload it. And there we are. It says library is now managed. The original file can be found here. And what I want to do now, I could click OK and continue working, but I'm going to pick View on Web. Okay, and this is going to take us to library.io. Have to be careful because it has a whole bunch of windows open. Let's see. Oh, I see it. It's over here. Alright, I'm going to bring it over here. Okay, we're going to go to library.io. And if it's still logged in with Ed's account, yeah, still logged in with Ed, so I got to log out here. Sign out, sign back in. Again, everybody look away. Alright. There we go. So we should be able to see it. Let me make this bigger. Okay, and when you log in, this is what you're going to see. These are the managed libraries I have created previously. Okay, here's the one we created today. You'll see also that you have a packages section. These are all the packages that are in your managed libraries or that you create online. So anything that you've ever managed shows up here on an individual package basis. Okay? And then you have 3D models. Same idea. Any 3D model you've ever used or you've ever created is available here individually.
No models could be downloaded, can't they?
They can be downloaded, so if you need to use them in a different tool, you can export them here as step or object files. So you can have your own 3D models and use them in whatever tool you would prefer. And you can do something similar here. with the packages. So what we're going to do is we're going to go to the library.
So when you download the package, it's in Eagle format, and it has the associated 3D model as well as the package?
Correct. Correct. It's gonna, when you download it, it's going to download basically just as a standard Eagle library. So I've clicked the base library. Okay, and we can see here my two parts that I have, my two main components, symbol. Now, package on library.io is the 3D package. It's not referring to what Eagle calls a package. Those are footprints, okay? And the nomenclature is going to be updated shortly to reflect, to line up with how library.io calls everything, since now Eagle can itself include 3D packages. So if you notice, we have these little exclamation marks let us know that we have a missing package. Okay, what I'm going to do is I'm going to click Edit. Okay, we can see here that you get the default rectangle. And its dimensions basically are based on the extreme dimensions of the footprint in Eagle. Now, if we look over here, we have the option to upload our own step model. We can add a model from our collection. So you can see here we have the My Model section. Or we can even go to all the models that are available on library.io. So if I want to do a quick search, I can just here, because this is a DIL 16, it's very common, so it's unlikely that we would need to build it from scratch. So I could just pick one of these. Let's go with that. It'll load it. Obviously, orientation is not correct, so we'll rotate it. And there we are. Perfect. So in this case, because it's a very common part, we can reuse what's already done. There's no need to reinvent the wheel on things like this. You know, you don't have to go and create a brand new package from scratch or a brand new step model. Just use what's already there. A couple of options here in the editor. For example, sometimes you want to be able to see kind of in an X-ray vision.
That's usually my workflow right there.
Yeah, I tend to prefer this as well, especially if I want to make sure that I have enough height, enough clearance from the surface of the board. I find this to be pretty helpful. Now, these other options, I'm only going to mention them briefly, but sometimes you're going to get a step model from a manufacturer, rarely, but it does happen, where the origin of the file and the model are like miles apart. They're like super, super far away from each other. And when that happens, you may notice that you import the model, you uploaded the step, and you get nothing, or what appears to be nothing. However, if you zoom out, you'll probably find that the model ends up being off in space over here somewhere. Okay, when that happens, you can use the model centroid option, and that'll reference the origin of the part to the model centroid and not to the file 00. So that's something to keep in mind. Okay, so this one's ready. You'll notice that we're in a draft state. Okay, whenever you see draft, that means you have to save the changes. So click draft. I'm going to create a new version. Mapped 3D model. Okay, I'll say create. Okay, and now it's green. We're good. Now, if we go back to the library editor now, we're going to notice that there's an update option, okay, because the library itself is also in a draft state. So we want to first update it to include that change, and we can do it by clicking Update All or clicking Update Here. Now, using the latest version of the package, would you like to create a new version of your library at this time? You can say Create, and it'll automatically create it. Okay? If you always like to have your own message, your own description, you can say no, and after it updates, just click on Draft and put in your own. So right now, as we can see, we have the library up to version 2. Ed, I think you have a little bit of echo, if you want to. Okay, cool. So right now what we're going to do is we're going to go back to Eagle. Okay, and obviously the process would be the same for the TSOP 20. I'm going to go back to Eagle, go into the library. I'll say OK here. And Eagle's already detected that there has been an update. Okay, do I want to update my local version to match the online version? I'll say yes. Okay, update complete. Perfect. So what we're going to do now, if you notice, there's our 3D package. It gets recognized. Now when you see the gear, basically it's Eagle downloading. It's Eagle trying to load the 3D model to give you the preview. Okay? And this is one that originally never got assigned a part, so it only has a rectangle. Now, locally, we can build our own models, so you don't have to necessarily go to library.io to generate your own package. So that's what we're going to do here. I'm going to click on Create with Package Generator. Okay, and as you can see, we have several different types. We can go down, and this is always going to be growing. Okay, so you don't have to worry too much if you don't see currently the template that you want to use. We're going to continually add to this to make more and more standardized templates. Now for the one I'm interested in, I'm going to go into this TSOP option over here. Okay, perfect. And what we're going to do is, if we look at the data sheet for this part, and the part we're interested in right now is the one that I have here, this PCM 5102A. Now you guys don't have that data sheet there. I'm briefly going to go in and just show it to you guys so you know what it is. PCM 5102A. Okay, it's just a little stereo DAC. Okay, download, download. Okay, and this is the part we're going to be interested in. Now, all data sheets generally will have some package information at the end. They don't always give you a nice table like the template has. So it's just a dimension drawing and you have to kind of fill in the values. Okay, and that's kind of what we're seeing here. We have the dimension drawing and we just have to fill in the values. So we go back to Eagle. Now I have this printed in front of me, so I'm going to go off of that. I won't be switching back over here. So if we look, we have that large D dimension. And what we can do is we can specify each dimension here. Let me go ahead and change the size of this, make it a little bit bigger. Okay. And if we look on the data sheet, we want to compare the dimension here to what's on the data sheet and just fill in the values. So first and foremost, this E, it gives me that it can be either 6.2 at a minimum and 6.6 at a maximum. So I'll put that there. I'll put this over here, 6.6. Okay, for the L is 0.5, maximum 0.75. I'm grabbing all of this straight off the data sheet. Okay, go over here, the B is the width of these, 0.19 to 0.3. Okay, the D is 6.4 to 6.6. Oh, not 4.5, 6.4. If anybody sees me put in a wrong number relative to what I'm saying, just yell at me.
It goes red.
No, I'm saying, like, if I'm saying 6.6 and you see a 7 point something come in, yell.
Okay. So just to remind everybody, this package calculator that Jorge is using, it's actually from library.io, but we're able to access it directly from Eagle as well.
And then the A is that height information, 0 and a 1.2 max. Okay, A1. It's going to be 0.25, 0.25, we'll leave it at that. Map still screen, and now what we can do is we can do update preview. It'll go ahead and generate it for us.
While that gets generated, Jorge, let me just explain the benefits of this. In addition to actually having the 3D footprint created as well. I see that you have a little bit of air. You got to fix
I missed something.
The body size there a little bit. But just to let everybody know, while we're here, it's not only that it's creating the 3D model, it's creating the package. In other words, you don't have to be taking into consideration grid. You don't need to be taking consideration spacing, that you place them accordingly, and the size of the pad. None of that has to be taken into consideration. What you do is you just transfer the details of the component into the package calculator, and the package gets created as well as the associated 3D symbol. That is a huge time saver because creating the footprint might be one of the most difficult portions when it comes to creating your custom parts.
Okay, so I found my mistake. I hadn't put in the pitch. I did skip that one, but now it looks good. Now we have it nice and correct. No, this one's 20. This particular one is 20. Because this is for the PCM 5102A, not for the SN. The SN is 16 pins, but this one is 20 pins. This is a DAC. And I'll pull up the data sheet again. Version will be created in your package, will no longer be editable. Yep. Say OK. What we're going to see is that we get that new package in here.
Hey, Jorge, they're asking me if we're using IPC 7351B or 7351C. If I'm not mistaken, it's the B.
I thought it was a C, so.
I think we'll try to verify that before the end of the webinar.
Yeah.
C is not a release standard yet, but all of our IPC calculation standard is based upon the B revision of the IPC 7351.
Yeah, that's what I thought.
There you go.
There you go. We got it before the end of the webinar.
Woot.
Okay.
Thanks, Sam.
Appreciate it, Sam.
So we've added that 3D package that we've created now, and what we can do is we can go into the device, which is the one we're interested in. There's an option here called Replace Package, and this is new. Okay, because originally I just had the package, I didn't have a good 3D model with it. If I click Replace Package, I can select this one, and all of the connections get preserved. So it is a direct replacement. All of the pin names and everything will line up. So if you look here, we shouldn't see any of these numbers change once I do this replace. So I'll say OK, and there we are. All the numbers stayed the same, but now we have it mapped to 3D. So this is new. This is a new feature that came in, and it makes it really easy to swap out an old non-connected 3D part to a new package that contains a 3D footprint. So that's pretty sweet. So we can go back to the library contents table of contents view. And what we're going to do is, because we love all these new tools, but we do want to address that sometimes you do have to create a part almost from scratch, basically starting, making it from the ground up. And that's what we're going to do here. So the part we're going to make is a TPS 92411. Let me go ahead and bring it up so you guys can see what it is as well. TPS 92411. It's an offline switch is what it is. So, okay, let's go over here. All that, okay. It's a very simple part. It's a good candidate for starting from scratch because it's simple and it's going to work within the time that we have for this webinar. So what I'm going to do is I'm going to again take you to that last page that has the information, and this one's really nice because this one, they give you a preview of what a 3D model should look like. They give you the package dimensions. and they give you the LAN pattern. Now again, for this example, we are going to demonstrate how to build a part from zero. Obviously, this is something that's very amenable to the package generator, and you can use it to double check your work if you wanted to. Okay, so I do have this one also printed in front of me, so we won't be using it again for that purpose, for the purpose of getting the dimensions. However, I do want to illustrate the smart paste and kind of use it live, because there are a few details here that we want to keep in mind. So here we have all the pin names, correct? So let's go back to Eagle, go into the Manage Library, and I'm going to create a symbol. Okay, this symbol is going to be TPS 92411. Create, yes. Okay, and here we have our nice symbol editor. And what we're going to do is we're going to use a smart paste functionality. But I want to show a caveat that you need to be aware of here. Okay, I have opened this PDF within Chrome. Okay, so this is using Chrome's PDF plugin. And what's going to happen is, if you notice, ideally we would just want to have the name, but it wants to grab everything. Even if I try to just stay in this column, it's going to grab everything. Okay? And there's nothing I can do to really force it to just grab that column. I can hold Alt, I can hold Shift. Okay? So what we want to do is, whenever we want to take advantage of this, the best option is to actually download it and open it with Adobe Acrobat. Now, we did download it previously, but I'm just going to go ahead and download it again. Okay, show in folder. I'm just going to right-click on it and make sure to open it with Adobe Acrobat. Okay, when you open it with Adobe Acrobat, you have this option if you hold down the Alt key, and you'll notice that the selection will change. And what this allows you to do is it allows you to make a rectangular selection and just grab the part of the information that you're interested in. So this is the part I want. I press Control-C to copy it. I go back to Eagle, Control-V, and magic happens. Okay, we'll see that some pins have been renamed because there was no connects. Okay, but as you can see, very simple, very straightforward. We figure that most of the time users would prefer to do this than to go through the Excel way, making a complete table. But as Ed mentioned, in large parts, large BGAs, it actually may be beneficial to specify all of the IOs and what type of connections you want to make visible, all of that stuff. But usually, it's enough to just get the names. Now, you'll notice that following Eagle's convention, you can't have pins that have the same name, so they each get tacked on the @1, @2, @3, so on and so forth. Now, for our purposes, because we're not building both versions of this part, we don't need the no connects. We're just going to build the SOT23 5L part. So I'm going to go ahead and delete these pins. So I'll activate the delete command. Okay, I should have just deleted the 3, which I did. Sometimes it can make it very nice to see the pins, so that way you see how everything's kind of orientated. I'll go ahead and drag this pin down, make it nice, form a group. We generally recommend that you try to center the symbols, at least as best you can. Makes it easier later when you go to place it. Now we can use line tool to draw a border around our symbol. Beautiful. Okay, always remember you want to put in the name and value text variables, and you can do it manually, greater than sign, name, so on and so forth. But you have to remember to put on the right layers, and it can be a little bit error prone. What we recommend is you go into the UOPs, and Eagle ships with one called Set Name and Value, which is this one right here, and it will just automatically do it for you. And then you can just locate them. They automatically get placed on the right layers, so you don't have to worry about getting that correct. The last thing we want to mention here is that you also want to make sure to assign the directions when that's important. If you need to adjust, certain pins are swappable, all of that needs to be added. For our purposes here, in this part, the only change we're going to make is for the power. So we're going to go ahead and do that. Give me 1 second. We can do it through the info command. It's probably how most users find it easiest to do. Okay, info. And for this, VIN is a power pin. You just go over here to direction, set it to power. And VS is the source, so I can leave that be. Everything else should be okay. If we really want it to be very specific, drain is an output only according to the datasheet. And again, this is just coming straight from the datasheet. But setting these directions can help you when you're running your electrical rules check. It'll catch any type of mismatch. You know, like if you connect an output to another output, generally that's bad, so you would complain about it. If you have something that's a no connect, an NC, and then you do connect something to it, the electrical rules check will flag that. So it is in your interest to set these up and make sure that your library symbol is giving you as much information and is doing as much work for you as possible. So this symbol's done. We can go back to the table of contents. What we're going to do now is we're going to create our own package. Okay, and this is a SOT 23. 23 5L. Okay. There we are. Now, again, we can go to the data sheet. I'm going to bring it up just for 1 second. I want to highlight something. There is no such thing as a standard data sheet. Every company does them differently. Every company, even between parts, will have different formats depending on the department that made it. So sometimes it will be very easy to parse the data from the data sheet, like in this case. Everything is being dimensioned off a center, and you have all the extra dimensions you need, and it's really, really nice. In other cases, you may even have to pull out a paper and pencil and start working out, you know, where this point is or this other point. But kudos to TI. This is a really easy to follow example. So we're going to roll with it and just using the dimensions place our parts. Now something that can help is setting up your grid to make your life easier. So I'll go back to Eagle, go over here. So we're going to use SMD pads. The size is already specified in the datasheet. The size is specified in millimeters, so I'm going to go ahead and change my grid to be in millimeters. Okay, perfect. Let's go ahead and put in the sizing for this. It is 1.1 millimeters by 0.6. Okay, so there we are. Now, one thing you can do to make your life simple is you can set up the grid in such a way that you place the parts just by clicking. You don't have to enter specific points in the command line. So on this part vertically, the separation between parts is 0.95. So I'm just going to set up my grid to be that, 0.95. Say enter. And I put one here, I put one here, I put one here. Perfect. And then what I'll do is I'll go ahead and for moving them over, because they need to be over 1.3, I can just very quickly set my alternate grid to be 1.3 millimeters. Okay, and what that's going to do now is after I place these, or if I hold Alt, I can move the appropriate distance. So I'll hold Alt, now the alternate grid is in effect, and I can move over 1.3. So I can move over 2 units, or I can stay on that 0.95. Okay, so what I'll do is, since these three have been made, I'll go ahead and relocate them just to make it easy. You can use the move command itself, control right click moves the group. Okay, and right now it's moving in units of the default grid. If I hold Alt, it'll move in units of the new grid, of the 1.3. So there we go, 1.3 there. Perfect. And now what I'll do is I'll place my remaining 2 pads. I'll put them over here. I'll form a group that contains just those. Move again. Control right click to perform it on the group. And now again, if I hold Alt, I'll move the appropriate distance. So now these pads are all in the right places. And I didn't have to type any points on the command line. It was just messing with the grid. Okay, and this is the basic land pattern. This is actually enough to get the design done. The pad names are not in the correct order, as is obvious, so we want to go ahead and change that. We can do that using the name command. Click over here. 1, 2. In Eagle, the commands stay active until you choose something else, so it's very easy to group the same operation over and over again. So here's 3, here's 4, here's 5. Okay? And this is the recommended land pattern. We're following exactly as it is specified here in the datasheet. Now, another thing we could add, just to make it a little bit more accurate if we wanted to, is we could put in the outline, okay, of the component. And this component roughly is 1.75 millimeters by 3.05 millimeters roughly. So here we would have to do a little bit of math just because we have everything centered. And this is a big recommendation when you're drawing your own parts. You want to make sure to have everything around center. It's going to make it easier to select the part and move it around, and it's just easy to reference the center point of a part. So let's go ahead and do that. I'm going to go ahead and just do some quick little math here. 1.75 divided by 2 is 0.875. Okay. And then the height, 3.05 divided by 2 is 1.525. Okay. So what we can do is we can go ahead and add the silkscreen for it. So I click over here, make sure we're on the right layer, which is going to be T-place for this. Okay, thickness, we would want it to be, that's okay, that's a good thickness. Okay, and now what I can do Control L and start typing in the command line to different points. Because everything's centered, it's just changing the signs. So it'd be 0.875, 1.525, and we can put them all in one go, or we can do it a little bit at a time. So what I'm going to do is I'll put these first two so you can see what's happening.
You know, Jorge, seeing you do all this gives me that much more appreciation for the package calculator.
Yes, package calculator rules. Okay, so as you can see, it started over here, came down, and now I just keep going around. La 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 la. It's very mechanical, and you can see how much time you can save by using the calculator. And hopefully I didn't mess up any of these signs, because if not, it'll go off into space somewhere. Nope, I got it. Okay, so I can press escape, and that's good. Now, with a little bit more effort, you can actually even create the little separations in here, but usually on a part like this, as soon as solder hits that ink, it'll burn off, so you don't have to be too concerned. But if you wanted to take it to the next level of refinement, that would be the next step. Again, we do need our name and value, so if you right-click on the UOP icon, the list of most recently used UOPs pops up. We see that we used set name and value before. I press it. There we go. And we can just go ahead and put it where we want. Okay. Now we go back to table of contents. I'll go ahead and save my changes. Now something is going to happen when I save my changes. Okay, everybody look at the top toolbar. File, save. You'll see that you get version 2 plus edits. Okay, what this means is that I have local changes that have not been committed to the cloud version. Okay, and it's extremely important that you are always aware of what version your cloud library is versus your local library. Again, in future versions of Eagle, the local library is going to become pretty much the sole factor to keep track of here. But right now, during the workflow that we currently have, you have to be aware of where your online library is at and where your local one is at. You kind of always want to keep them at about, par. Because what can happen is if one goes too far ahead of the other, and then you try to sync, there's a possibility that if you made local changes and your cloud library, for example, is a higher version number, you can clobber your local changes. Okay, so it's very important to keep track more or less of where you're at. So right now I've made these local changes. What I can do is I can go library, create new version. So now I'm pushing the local changes to the cloud. New version will be created. Da, 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 da. And now we're at version 3. Okay, and you can see Eagle is happy, the device is mapped, everything is cool. So now what we're going to do is we're going to go ahead and create the device for this part that we just made, this TPS 92411, okay? So we're going to go ahead and make the device. And this is arguably the easiest part. So we click on Add Device, create a new one, TPS 92411. New device, yes. Okay, first thing we want to do is we want to bring in the symbol. Okay, try again to center it over the origin. Then we can add the new package that we made. Add a local package, that's the one we're interested in adding. Say OK. Alright, right now I'm just going through the fundamentals. I'm not concerning myself with the 3D part. This is just the bare bones to have a part that works in Eagle. Okay, we want to set up a prefix. This is an IC. Okay, and now we're going to go ahead and connect it. Okay, and this is just an exercise of looking at the data sheet and seeing what pin goes where. Okay, so pad 1 goes to the reset pin. Pad 2 goes to the VS pin. Pad 3 goes to VIN. Pad 4 goes to drain. And pad 5 goes to the RSNS. Okay, everything is mapped. We can say OK here. And perfect. Now, for your own libraries, it's usually a good idea to put in a description. And here, we're basically using just HTML. Okay, so I could, if you're familiar with HTML, I make a bold tag, I put in the part number, TPS 92411. I close the bold tag, put in a break. Okay, offline, AC, floating switch. And I can put another break to make a new line. We can also put in a link to the data sheet. So I'll do that, ahref, go back to Chrome, just copy this. Put it in there, Control V, parentheses, close it, data sheet, -A, say OK. Again, you may want to have a more sophisticated description than this, and I encourage it, but just for the purpose of the demo, we have this, and the link works well. You know, anybody else who got this part, they click here, and they would go and open the data sheet. So definitely something that's useful to have in your own personal libraries. You can also link in pictures in the description if you wish. So really there's a lot that you could do here that I think a lot of users aren't aware of, and that's why I wanted to take the time to kind of highlight it. Okay, so at this point we have our device made, everything is ready. We can hit File, Save. Now we have version 3 plus edits. Library, create new version. Okay, and if we now go online, we want to view this on web. We could go here, View on Web. It opens again. and we'll see that it is the updated version of the base library. Okay, it has our new parts, as you can see here, our TPS, our TP902411, I forgot the S on it. And again, we can assign models to this. So it's in a draft state, I can pick this one, edit, assign the model, and the process repeats. Okay, so this is essentially what we wanted to focus on for this webinar. So I'll go ahead and turn it over to Ed to do a final recap.
So in essence, what we demonstrated today was how to work with the Eagle Library Editor in conjunction with the library.io website, which is actually hosting your managed libraries and your map 3D models. So there's many workflows. And actually there was a really good question here, Jorge, which I would like to share with everybody else. And it was the question was, can I work with 3D packages without having to manage our library? Want to go ahead and answer that one, George?
Yes. So you don't have to manage the library in order to be able to use a 3D package. In fact, let me go ahead and save this. Well, it's already saved. It's already a version 4. I'll go File, New Library. Okay, and you can go over here to 3D Package, Create with Package Generator. And you can create the footprint as well as a 3D model without making the library manage. So that is possible. It is possible to, and I'll just go ahead and pick one of these randomly. Just use the default values, update preview.
In addition to this option, you could select models that already are on library.io.
Correct. Okay, it's creating it, and it'll go ahead and place it here on this new library that isn't managed. So you'll see that even an unmanaged library can still contain 3D data. And that's something that has helped make the workflow even more agile.
In addition to that, Jorge, can you click on the Import 3D package and navigate to another library? That way they could see you could actually select packages that are already 3D map in other libraries.
Oh, great. I had to pick a library. It doesn't have anything mapped.
Go to the 40XX. That one has plenty of them. Oh, you gotta go there as well.
And there we go.
See, what I just want to be able to demonstrate is that the library does not have to be managed for it to have its map 3D models as well. Okay, let me see. Now somebody's asking us for a way to merge or split a managed library so one can put certain parts in a different folder, George. And that actually can be done.
Yeah, so probably the easiest way to do it in that scenario, if you want to split it, probably to import it into a new library. Since we have all the import functionality available on these buttons, you can just go File, Import, and then just import the specific parts that you want into a new library, and then clear out the old one of whatever you don't want to have in it. That's from the user perspective the most straightforward way to do it. If you're feeling fancy, you can go into the XML and tamper with it there. But that carries its own set of risk if you don't know what you're doing. So I would probably recommend to go the user interface route, the GUI way.
My preferred way is actually having the library open side by side with the Eagle control panel, and then just drag and drop parts that I want from one library into the library that I currently have open.
That works as well. It requires that the library be visible on the control panel. But if that's your use case, and yeah, that's easier also.
Yeah, it's a bit more visual, so it lets me navigate all the libraries. That way I could base my custom library off of different libraries as well. There's another question here in regards of, are we going to get rid of our local libraries and go strictly with managed libraries?
Heck no.
No, I don't think that we're going to be doing that anytime soon. Yeah, the local libraries need to exist. Not everybody who actually wants to manage a library. So I don't think they'll be implementing that anytime soon. I don't think they're going to be getting rid of that anytime soon. Okay. Now, how do I assign the same 3D package to other parts in the same library, such as having a SOIC8 parts using the same 3D model? Actually, this could be done in the device editor. What you do is that in the device editor, you're going to have the option to select a package. If you select one of the packages that already has a 3D model assigned to it, it automatically comes with it. Okay.
Yeah, it's a package deal.
So if it's already in that library, it's actually really easy. If it's in another library, you could actually navigate to the library and grab that package that has an associated 3D model already. Okay, so it's actually either scenario actually works. Okay, now okay, I don't see any other questions so far. Now, hey Sam, you wanted to remind?
Well, I see a few over here before Sam comes in.
Oh, okay.
So I have one here. Again, somebody asked that whole standard libraries thing. That's already been answered. So we definitely are going to continue to have the standard libraries. There's too much that's still carried by them. The other thing that we want to do here is the question here: how do we create non-rectangular and non-circular pads? It is possible in Eagle, and it's done through arbitrary pad shapes. And basically the way that works is you start with one of the default pad shapes, be it a VIA or an SMD, and then you use a polygon to kind of form whatever outline you need. As long as the pad or SMD is within the polygon, Eagle sees the polygon as an extension of the pad. The solution is not 100% ideal because you still have to manually draw in the stop mask. I apologize. The stop mask and the cream mask, but that's the solution we have for now. For the slots, if you're making slots, then you have to draw those on the milling layer and export those as their own Gerber. Again, these are workarounds that we have right now, and we do plan to address those needs in a more formal way in the near future. So for Amaldev, hopefully I didn't mispronounce your name, or Amaldev, that's the answer to your question. Right now, you have to use the arbitrary pad shape functionality if you need to do any arbitrary size type shape, and you have to use slots drawn on the mill layer to be able to make slotted drills. Ole has a question about the update process of Eagle. That's something that we do plan to improve to make it a little bit nicer. And there will be some improvements in the very near future, so stay tuned to that, Ole. Okay, I don't see anything else besides those.
There's a question on ECAD.io. Well, ECAD.io is up and running. It can generate a step file of your entire design. I think that's
ECAD.io hasn't come up. It's up in a week.
Oh, okay.
In about a week, it's going to be up again, and it will be available up until August 25th.
Yeah, so it's going to be up, but it will be temporary, just to let you know. Okay. So if you have a need for using Eagle 3D models, we strongly recommend that you use Fusion Team, which basically uses the same workflow that we have right now using managed libraries and map. And Fusion Team actually gives you the capability of exporting your design in multiple formats, and STEP being one of them. Is there any other questions? How do you generate step files for people who do not have Fusion 360?
So that's through Fusion Team. You need to be able to access Fusion Team. And then once there's the option to export your design data in a whole bunch of formats. Step files, I think there's SolidWorks files as well, and a few others. But it requires having access to Fusion Team. So if you don't want to use Fusion 360, you would still need to get Fusion Team.
Also, Nathan is asking us if the best source for our tutorials is YouTube, and to be honest with you, for now, it actually is. That's where we're hosting them. Now, there is going to be some changes in which we will be hosting many of them. There's several of them available on our website, but through YouTube, it's just faster to be able to post them. But we'll be adding these to our site as well at some point. Okay. I don't see any other questions for her right now. Okay. So in the meantime, if you have any other questions, I'll like.
Question that came in: what are the advantages to use managed libraries instead of standard libraries? So right now, the biggest advantage of managed libraries is going to be the integration with Fusion 360 and the ability to manage the library online. As time progresses, it's going to be the easier mechanism for sharing libraries. Right now, that feature isn't implemented. However, we are getting closer to it, and that's going to allow you to very easily control who can access your library. So if you're working in a team, you can define for the team who has access to the libraries. It's going to make it easier to maintain that central repo.
I would like to also add that the fact of the managed library allows you to do your mapping of the step models, as well as managed library allows us to be able to provide manufacturers an account in which you could access their libraries through our managed library system.
Correct. So that's the other big advantage. Within Eagle, I don't know if anybody's seen it. Let me go ahead and show it now that we're on that subject. I'll go ahead and close this because we don't need that. Let me see if it's here. No, I have to open a design. Over here, control panel. I'll just use this one as an example. Okay, if we go here to Library, Open Library Manager, there's In Use, In Design, and Available. The available are obviously the ones that you have in your setup, the managed libraries you've created, but also you'll see that we have Adafruit, there's SparkFun's LilyPad library, there's a whole bunch of Seed libraries, a whole bunch of SparkFun libraries. So this now becomes a means to be able to get additional libraries for Eagle without having to go online or trying to download from GitHub. So that's the other kind of big change. There's a question here. Is an Eagle a way to make pads on middle layer when designing? Oh, no.
No, not yet.
No, currently we don't have any mechanism for making pads on internal layers. You can fake it. You can work around it using, with the layers and drawing certain features, but you have to do it manually. There's nothing nicely integrated to support that workflow for inner layer components.
Hey Jay, take a look at the chat window. That's where we're posting all the links. Okay, Jay. Now Gerald said that he has a question, but I don't find it, Gerald. I'm sorry.
Could you post it again, Gerald?
Yeah. Do you mind posting it again, Gerald? We definitely want to answer it, but I didn't see it. If you don't mind.
Okay, missed the first few minutes of the webinar. As an example, in creating an MCAD device, created a symbol for port A with PA. Okay, so let me ask you, that symbol, port A, contains the 7 pins. It's not that you took one pin and you named it PA 0.7. I'm pretty sure that's not what you did, but I want to make sure. Because it is possible to have multi-gated parts. So for example, in the case of the ATmega device, you could have a symbol for port A, symbol for port B, symbol for whatever other functionality that microprocessor has, and then all of those together, all of those different symbols become that one ATmega device. So it becomes a gated symbol, basically. So it is possible, and it's actually very easy. What you would have to do in that situation is probably rename the pins, is what I would do. So for example, if you want to make it very general, you could say the name of the gate, once it's in the device, could be port A, and then the pins would be 1 through 7, for example, or sorry, 0 through 7. And then you could use that multiple times, and you would just rename the gates. So gate, the first gate would be port A, Second gate would be port B, so on and so forth.
Just like a multi-gated component. Just like you were treating it as a multi-gated component in Eagle.
Yeah, let me just really quickly illustrate that, just to make it easy. Okay, so it'd be something like this. Okay. I'm just winging it to get the idea across, so it'll be really quick. 5, 6, 7, 8, okay. Name. Oh, I should have done it the other way. That would have been faster than this, but okay. Okay, 7. And then we do this. Okay, name and value goes in. Okay, let's go to device, add a device, X mega. Okay, and then you would go over here to the symbols. You can pick ports, and let's say there's 3. So 1, 2, 3. And what you would do is you would go with name, port A, port B, port C. Something like that. Okay, and then when you went to connected, I wish I had a package that was big enough to do it, you would see that all the pins are named appropriately. Port A0, port A1, port A2, so on and so forth. Okay, so that's one way to do it. Does that answer the question, Gerald?
Okay, I think it does.
Yeah, if you did want to very specifically rename the pins, then yeah, you would have to make separate symbols for each one.
Exactly, yeah.
If this wasn't acceptable, you would have to do PA0 as, that's set as one symbol, PB as another symbol,
exactly.
PC as another symbol.
Correct, yeah.
But if this works, then this is a little bit easier. It all depends on what you need.
Well, I don't see any other questions. I think it's a good time for us to stop the webinar. We went over a little bit of the time that we usually use, but we wanted to definitely give you as much detail as possible and answer all the questions available. Hey, Jorge, could you put our support email there on the chat group? That way everybody knows how to contact us and reach out to us. Make sure that you're signing up on our Autodesk site. That way we could keep sending you notifications of all of our webinars as well as offers. Also, we would like to let you know that we have a very active Autodesk Eagle forum. We like to invite you all to join us there. It's very active and very informative, so we're constantly answering questions fairly fast. And not only by us, but contributions made by some of our high-end users as well, very veteran users using Eagle as well. Well, I think we could go ahead and cancel right now. Make sure that you reach out to us. Thank you very much. Hopefully it's been a benefit of everybody. Have a great day.
All right, bye everyone.
Have a great one. Thank you.
Bye. For the last question, you can't mirror the gates here. You have to mirror them on the design. In the device, they're all always oriented, however the symbol was made.